What's the point of studying derivative? Well, let's say before, we had an optimization problem. Let's do it again. Now we're trying to maximize the volume of a box. So a box is XYZ. We also have the surface area of each face. So each face is going to be XY or XZ or something along those lines, depending on the orientation of the face. So let's say we have 120 square centimeters of cardboard, and we want to find out the maximum volume that we can, given the constraint that the top layer of the box is not there, so it doesn't have a lid. So that would be this part is missing, and we can say that these two are X and that one right here would be H. So then our volume becomes X squared H, and our surface area is going to be our total areas of each of the faces. So that gives us X squared plus XH plus XH plus XH plus XH plus this area right here on top, which is 0 because it's open, there's no lid. And we have the four faces, 1, 2, 3, and 4, which are XH. So our constraint is going to be X squared plus 4XH is equal to 120. And we want to maximize our volume. Now we plug our constraint into our volume. Volume is equal to X squared times, well, we're going to have to solve this one for H. X 4XH is equal to 120 minus X squared. That means H is equal to 120 minus X squared over 4X. So then our volume is going to be X squared times 120 minus X squared over 4X. And this is going to cancel. So our volume is this X times 120 minus X squared, or 120X minus X cubed. Of course, that's divided by 4. I missed that. And our volume is then 30x over x cubed over 4. Now to optimize this, we take the derivative of the volume and set that equal to 0. Oh, I forgot an x right there. Sorry. So that volume prime is equal to 30 minus 3x squared over 4. And we set that equal to 0. And then we solve for x. So our x is going to be equal to the plus or minus 2 times the square root of 10. However, because this is a real problem, real physical problem, we cannot have negative volume or negative length. It doesn't make any physical sense. So our x is going to be 2 root 10. And we could take a second derivative, which would be minus 3 times 2x over 4 and this is a less than 0 for our 2 root 10. So this would mean it's a local maximum and that it's concave down at that point. Now what is the volume? Well, we have x is equal to 2 root 10. Our height is, we said it was h is equal to 120 minus 40 over 4x. Oops. 40 is the value when we plug it all in, but this is x squared. That's a horrible x, but so 120 minus 2 root 10 squared over 4 times 2 root 10 is equal to, and after doing some algebra, some basic arithmetic, 120 minus 4 times 4, not 40, 4 times 10 over 8 root 10, and this is 120 minus 40 over 8 root 10, and that becomes 80 over 8 root 10, or 10 over root 10 times root 10 over 10. That's 10 root 10 over 10, or just root 10 for our h. So then our volume was 2 root 10 squared times h root 10, and that's equal to 2 root 10 cubed, or 20 root 10. So we have a max volume of 20 root 10, and that's approximately 63.25. What did I say? Did I say centimeters, or yeah, centimeters? Centimeters cubed, with our x is equal to 2 root 10 centimeters, which is, this is around 6.33 centimeters, and our h was equal to root 10 centimeters, which was about 3.16 centimeters. That's pretty much it. I forgot to mention that the beginning, the sides and the base add up to 120 square centimeters. So that our total surface area is 120 square centimeters. We then found the expression for volume and our surface area, and used our surface area equation to plug into our volume. We found our volume using our constraint. We took the derivative, and then we also took the second derivative to see if it was a local max or minimum. We found that it was a local maximum. Our first derivative we set equal to 0, and we solved for x, and we had two values, but because one of them wouldn't make any physical sense, we only had one real value. We used that, and then we plugged that back into our expression for h, and then we found our two numbers, and we found our maximum volume given our x and h values. That's pretty much it for this example. Thank you for watching.